Good afternoon. I would like to present our project about encouragement of collaborative learning based on dynamic groups. So let's start. I would like to start with a motivation. Everybody of us know that collaboration and collaborative learning in groups is very important. And learning systems are places where users with different social contexts meet together. And thus it is important to support the collaboration during the whole group life cycle. But especially group formation is a place which can significantly influence following collaboration. Many methods exist which can solve group formation problem. But there are domains, for example, Coursera, as we mentioned it several times here, where these methods are not sufficient. And we identified several problems these methods have. For example, usually these methods are not universal enough. Also, they are static and do not consider actual student context. And they are limited in sources or information about students. And last but not least, we suppose that a teacher can significantly determine which aspects make collaboration more effective. In addition, group formation is not sufficient. It is also very important to design and implement collaborative environment and analyze collaborative education. Thus, we set a goal to support effective collaboration. And how? By proposing a method for automatic short-term and dynamic group formation, and by designing a collaborative environment for effective collaboration, and of course in CSCL domain. So our method for group formation is based on student characteristics. These characteristics can be personal or collaborative, such as behavior, knowledge, interest, or other characteristics, for example, gender, age, and so on. Our method creates a group automatically and iteratively without student participation. We decided to use optimizing approach, which is called group technology, in our method. This approach is inspired by optimization in industry, where we have groups of machines which participate in producing families of parts. And we have optimization problem, how to allocate these machines to minimize transfer and production time. Maybe it sounds a little weird, but we have a very similar problem. But instead of machines, we have students. Instead of parts, we have characteristics. And also, we are not trying to optimize production, but collaborative learning. Input data to our method consists of two matrices. Similarly, as some machine participates on producing a particular family of parts, also a student has a list of characteristics which are typical for him or for her. And in addition, similarly, as family parts are grouped together into families of parts, also some characteristics should be combined together to cause and to bring much more effective and successful collaboration. So calculation in our method consists of 4 steps. We describe this calculation in more details in our paper, so I will give you only a short overview of it. First of all, we calculate some clusters of learners and characteristics, and according to these clusters, we calculate relevance and similarity coefficients, and these coefficients are used to calculate a special matrix we named group compatibility matrix. Afterwards, clustering of this matrix is performed. And the result is that we have identified clusters of students and characteristics which are typical for this class, for these students. This cluster of students can be really big. They can contain 10 or hundreds of students, and we can create particular group from students within one cluster. We applied our method iteratively. It means that we are able to use some additional features. For example, we can use several matrices of related characteristics. It means that we can dynamically change the characteristics which are combined together during the experiment, for example. Also, it's possible to dynamically update input matrices during group formation process. It means that as soon as particular group finished their task solving, it's possible to update both input matrices. It means that we can use dynamic metrics of related characteristics, which solve our problem where sometimes we do not know which characteristics should be combined together. Also, it's possible to use dynamic metrics of assignment of characteristics to students. It means that we can continually learn students' characteristics. As I mentioned in motivation, it is also important to apply our method in some real collaborative environment. And thus we decided to design 7 collaborative tasks, for example, explain some term or list advantages or disadvantages of something. And we implemented 4 collaborative tools which can be used to solve these tasks. These collaborative tools are text and graphical editor, categorizer and semi-structured discussion. We analyze collaborative learning and we recorded several types of activities. These activities are used as our characteristics, so we focus especially on collaborative behavior. And these activities afterwards are used to calculate evaluation dimensions, which are based on some psychological studies. These dimensions are, for example, argumentation, reaching consensus, task, and time management. We implemented a collaborative environment as an application which is called Popcorn, or Popular Collaborative Platform. This is a screenshot from this Popcorn, and you can see text editor, graphical editor, and categorizer, which is here, and on the right side you can see semi-structured discussion. So we evaluated our method in 2 steps. In the first step, we evaluated preconditions of method in short-term control experiment. We confirmed whether activities form natural clusters which influence collaboration in positive or in the contrary in the negative way. In the second step, we performed a long-term experiment where we want to find out whether groups created by our proposed method can achieve more successful collaboration in comparison with the groups created by a reference method. As a reference method, we employed Cummins clustering. And you can see results here. Totally about 110 students participated in our experiment. 254 groups were created and students were iteratively assigned these groups. About 4,000 activities were recorded, and we also got a lot of explicit feedback from students. As you can see, our method, or groups created by our method, achieved the highest evaluation, and also students provided highest feedback. It is interesting where the groups created randomly achieved a little bit higher evaluation in comparison with groups created by Cummins clustering. We used ANOVA as a mathematical statistical system to evaluate the significance of our results. And we got a p-value 0.008. We can interpret this value as the probability 0.008, but our results are only some coincidence, and they are not caused by using different methods to create groups. So, to sum it up, we proposed a method for creating dynamic shortened groups, and we implemented a collaborative environment where these groups can solve their task. And in a long-term experiment, we found out that students have different collaborative behavior patterns, and thus it was possible to use our method for group formation, and created groups were able to achieve a really successful collaboration. At the beginning of the experiment, we don't know anything about these students, and each iteration makes group process much more effective and better. In addition, we received quite a lot of data during the long experiment, and nowadays we are working on integration this data with data from another learning system, and also with results from psychological questionnaires and tests. So that's all. Thank you.
It's not surprising that rather groups perform better than team clusters, because team clusters try to get different similar characteristics.
Yeah, homogeneous groups. Yeah.
Successful groups have different people who complement each other, who practice similar each other. The same time as apparently just learning methods that don't give such important skills to them. We would like to give an understand them of going hard to perform. Thus, in this case, we did about that. The reference we have to provide better feedback, but performance will go good. Other people provide better performance, but feedback will go good.
I don't know exactly. It seems that, as you say, Kramin's clustering created homogeneous, really homogeneous groups, and it means that students didn't feel very comfortable in this type of groups, so they provided a little more feedback. But it is interesting they achieved higher evaluation. Maybe, I don't know. I cannot provide an answer on this question. It's as we evaluated collaboration of these students, we use seven dimensions, and this average of each dimension. And dimensions are calculated, for example, if we have a dimension where students should participate in same time and divide to task between participants in one group, and if one student solved almost all tasks and second one only brought at the end of task solving, it's okay. We can finish. So then this number is very low, and if these numbers are automatically calculated according activities which were recorded during the collaboration. Yeah. Interval of these numbers are from 0 to 1. And feedback is from 0 to 5. They have a 5-star range. Okay, I prepared a slide for the situation. As I mentioned, we use as a characteristics information about which activities are typical for particular student. So if we found out that a particular student has a tendency to propose a better solution, so we created a characteristics. Yeah, this student proposed a better solution very often. So it means it's not main characteristic. For example, it's a student active and so on and so on. But we created a characteristic that some activity is typical for him. But it's also possible to use any other characteristic, as I mentioned, gender, age, interest, or knowledge of some learning objects, whatever. This method should work also with other characteristics. Yeah.
I got some notes from the program chair that you make the signal that you can say. Okay, so let's talk about that. Okay, thank you very much.
Thank you.